Okay, so some applications of percents. One of the applications of percents we'll look at is commission. Now, for you guys coming out of here with a welding degree, you're not necessarily going to jump in a commission field right away, but there's chances for advancements if you get into a sales rep, supply rep, stuff like that, where you could end up in a commission position. Most commission jobs are sales type jobs, but you can get in a commission production job. If you produce, you get where you have a base wage plus a commission percentage of the value of what you produce. So anyway, commission is just a percentage of either a production value or sales. It's easier to talk about it as sales, so we're going to look at it that way. So let's say that you're in a position where you're going to earn a 12% commission. And you have sales for the week of, let's say $18,000. Let's figure out what your commission is. Well, 12% is 12 over 100 out of 18,000. So you would cross, multiply, and divide. 12 times 18,000 divided by 100 is $2,160 is your commission for that week. Not a bad check. Now, we mentioned a little bit in our last class that we had that rate method of percents rather than using the proportion. The proportion is more accurate. It is more likely to give you the correct response. You don't have to worry about, do I multiply, do I divide, or whatever. But we'd also mentioned that there are some times where using the rate method is favorable. If you're always starting with the whole amount and you're just trying to find the piece that is represented by the percent, that rate method is a very quick and easy way of doing it. So for commission, that's how we're usually doing it. We have a whole amount and we're looking for the portion that's your commission. So if 18,000 in sales, we would multiply by, what is 12% as a decimal? 0.12. If we multiply that out, we do get $2,160 is the commission. So commissions is one of those cases where the rate method is preferred. Now, commission isn't always that simple where it's just a flat percentage of your sales or a flat percentage of your production. Sometimes you might have a wage plus or a salary plus. So you might have that you're going to get $800 per week plus 7% commission. So let's say you have a week where you have sales of $9,500. How much are you going to earn? Well, you're going to take your sales of $9,500. What are you going to multiply it by? 7% becomes 0.07, which is going to give us what? $665? Yes? No? Yep, $665. And then we're going to add to that the $800 for our base pay. So $1,465. You'll notice the commission rate was significantly lower because you have that base salary. Now sometimes rather than lowering the commission rate, they do something like this. They might say that you're going to get $600 per week plus 11% of all sales or production over $6,000. So what they're saying here is we're going to give you that $600 a week, but for that $600 a week, we're going to expect your first $6,000 in sales. If you want to get above that $600, you have to sell over $6,000. So let's say you have a week where your sales are $10,800. So your commission is the 10,800 times what? 11% is 0.11, which is going to give you $1,188, right?
Or wouldn't it be 4,800 is what we take commission?
Ah, good catch. Why couldn't I do that? is only get commission on what's over 6,000. Take the 10,800, we don't get commission on the full amount. We subtract that 6,000, so we're only going to get commission on 4,800 of it. Somebody's awake. That's going to be times our 11% or 0.11 commission. That's going to be what? $528 is the commission on that? Plus our 600 base, so $1,128 is our pay for the week. Make sense? I don't want to spend too much time on commission, so I want to look at the next application, which is a little bit more important, interest. Now we're going to start out by talking about something called simple interest. Simple interest is just that. It is the simplest possible way that interest can be calculated. Simple interest means you don't only calculate interest under one of two conditions. One, the term of the account, loan, or whatever it is hits the end, so you hit the maturity date. Or two, there's an action made on the account. So either a withdrawal or a deposit or a payment if it's a loan. Most of your car loans and house loans are simple interest because you have to make a payment every month, so they're going to figure out the interest every time you make a payment. But if you don't make a payment, they don't figure out the interest. So anyway, simple interest, the amount of interest, which is I, is equal to the principal, which is the amount of money you start out with, times the rate, that is your percent as a decimal, times your time. And that time is always in years. So let's give you an example. Let's say you're going to invest $4,000 at 8% for 3 years. What are you going to have at the end of the 3 years? Well, the amount of interest, what's our principal? That's the $4,000. That's what we start with. Times, what's our rate? 8% will be 0.08. And our time is 3 years. What's that, 960 bucks? Now that's not what we're going to have at the end. That's the interest. So the amount we're going to have at the end, you have to take the principal of $4,000 and add the interest of $960 to it. So we will end up with $4,960. Now most of the time they're not going to use simple interest on something that's 3 years long, are they? Simple interest is generally used for shorter term things. For example, you might go to the bank and ask for a loan. So you're going to borrow $2,000 for 3 months. And the bank says they're going to charge you 9%. Now this sounds kind of silly, but it's something I used to do quite a bit. I used to run a construction company, and every now and then you get to a spot where you haven't finished a job yet, so you haven't been paid by a customer, but it's payroll time. You got to pay your employees. You go to the bank and get a small swing loan like this to pay your employees, and they're going to pay it back in 2 months or 3 months or sometimes even 30 days. So how much would you pay back here? Well, the first thing you got to find is the interest. I equals what's going to go in here? 2,000 will be the principal, times 0.09 is 9% as a decimal. Now we said the time is always in years. Here we have 3 months. 3/12. Or 0.25 is what it would be as a decimal. I'm just putting it as 3/12 so you can see that it's 3 out of 12 months. So now you're going to multiply that out. What do you get? 45 bucks is your interest. So that means at the end, you're going to pay back your original $2,000 plus 45 is $2,045. Any questions on that? Now let's go back to this example, 3 years. Right here. We said that most banks won't let that account sit there for 3 years and not put any interest. I mean, they put the interest in at the end before you paid it back. But normally, anything longer than 6 months, the bank's going to figure out interest and add it in as you go. It's called compounding. What compounding is they add in the interest at regular intervals. Now, if this is an investment, the nice thing about that is now, once they add in the interest, you get interest on top of that interest, hence the term compounding. If it's a loan, it sucks because now you're paying interest on top of that interest. Now, we'd mentioned car loans and stuff like that. Those are simple interest. I want to show you a neat little trick with a car loan. Let's say you have a car loan for $10,000 at, let's say it's at 6% interest. And your payment, we're just going to keep it simple, it's $500 a month. Okay? I'm going to compare two things here. I want to make a payment every month, at the beginning of every month, for the next 3 or 4 months. So I'm going to make the payment each month. So the first month, you're making the payment, $10,000 minus your $500 payment, you're at $9,500. That's why I said at the beginning of the month, because there's no interest if it's the beginning of the month. Now for the second month, before you can make your payment, they're going to do what? They're going to add in interest. So your interest is going to be the $9,500 times 0.06 times 1/12. 1 month is 1/12 of a year. Gives us $47.50. That's our interest. So $47.50 makes this $95.47.50. Subtract 500, now at $9,047.50. Make sense so far? No?
I'm a little confused.
Okay. Well, the first payment was made at the very beginning of the loan, no interest yet. So that's why you just took the $10,000, subtracted the $500. Second payment was made at the beginning of the second month. So you had to figure in the interest for the first month before you made that second payment. The interest is the balance, which is $9,500, times the rate, the interest 0.06, times 1/12, because it's 1 month, 1/12 of a year. So you got $47.50 in interest. So we added that on. So before they made the payment, they added in the interest. The balance before the payment was $9,547.50. Then we subtract the $500 payment. So that means we start the third month, or when we go to make the third payment, I should say, we're making the payment on the $9,047.50 times 0.06 times 1/12. $45.24. Now the amount of interest here should be getting smaller because the balance is getting smaller. We're making payments. So again, before we make our payment, we have to add in the $45.24. So before we make the payment, the balance is now up to $9,092.74. Subtract our $500, it's $8,592.74. Start a third month with that. We'll only go 1 more month, and then we're going to stop. So our fourth payment's at the beginning of the fourth month, or the end of the third month, however you want to look at it. The interest is going to be on the 8,592.74 times 0.06 times 1/12. $42.96. $42.96. So we're going to add that on. So $8,635.70. We subtract a $500 payment. $8,135.70 is where we're at. Now, what I want to do on the other side over here is I'm going to do this. I'm going to make 4 $500 payments right away. That's what we did over here, was we made 4 $500 payments, but each time we figured in the interest. Here we're going to make 4 of those payments right away. In other words, it's going to be $2,000, right? So $10,000 minus the $2,000 in payments, it's $8,000. So once we get to this point down here, we added in the interest 3 different times, 3 months, right? So to get to that same point, we're going to have to add in our interest 3 times. So 10,000 times 0.06 times 3 months, so 3 out of 12. Not 10,000, what's it going to be? 8,000 is our balance. There we go. $120 in interest. So it's $8,120 would be our balance if we did it that way. See, it says $15.70 to pay ahead. A lot of people, I'm going to pay ahead, I'm going to save all this interest. You can see they're making, basically only making 3 months ahead because you would have paid the $500 at the beginning anyway. You're only saving $15.70 in interest. Now, if that's a 5-year loan, however, if you're going to do that, every 4 months, make that big chunk of payments, yeah, it's going to save you $50 a year or so in interest. So be aware. Okay, so anyway, that's our loan example. Now let's get, you can see that the interest did compound because every month when you made that payment, the interest got figured in. Even though that was simple interest, they add in the interest every time you make a payment. You had to make a payment every month. What if, of course, there you had the payment being taken out, so the balance was being reduced. What if you're not making payments or adding money or drawing any money out of an account? Well, the way that gets figured, let's go back to that original example again. $4,000 at 8%. I'm leaving a little space there. For 3 years, I'm adding the phrase here, compounded quarterly. What's compounded quarterly mean? Every quarter or every 3 months, they figure out the interest and add it in. So let's look at each quarter here. So for our first quarter, the interest we earn is off the 4,000 times 0.08 times a quarter of a year, 1/4. You can put in 3/12 if you wanted to for 3/12, but it's a quarter. That comes out to be what? $80 in interest? Yes? So I'm going to add $80 in. We start out our second quarter with $4,080. So our interest will be 4,080 times 0.08 times 1/4, which is going to give us, what, $81.60? Does that look right? So we'll add that in. We now have $4,161.60. So we are going to start our third quarter with that amount. The interest in the third quarter is going to be that times 0.08 times 1/4. $83.23. So we'd add that on. Now, how many times would we have to do this to get through 3 years? Quarterly would be how many times a year? 4 times a year for 3 years. So it would be 12 times. I don't feel like doing this 12 times. So let's go back and see if there's a shorter way of doing this. First thing I see here is this right here. It's always 0.08, the 8% times 1/4. What is 0.08 times 1/4? 0.02. So what I'm really finding here is just 2%. If I found 2% of 4,000, that's my $80. All I did was found 2%. Once I found that $80, what did I do to it? I added it back on, didn't I? So if I look at this, the $80 was 2%. The 4,000 is what percent? Well, the starting amount is always 100%. 100% plus 2% is 102%. So what I ended up with at the end of each period is 102% of what I started with. Let's take a look at that here. If I start with 4,000, now 102% is what as a decimal? 1.02. I get 4,080. If I take that 4,080 and multiply by 102%, 1.02, I get $4,161.60. That's giving me my balances here. So what I can do is each period just find 102% or multiply by 1.02. How many times do I have to multiply by 1.02? 12 times. In math, do we have a function to multiply by the same number over and over again? Powers, right? So we can do 4,000 times 1.02 to the power of 12. It gives us $5,072.97. But that's compounding interest. Remember, simple interest, it was what? $4,960. That was simple interest. So we made $112, almost $113 more with the compound interest. That's a big deal. Let me show you why. How many of you guys are under 25? Most of you. Okay. So you get out of school. Let's say that you are, let's keep this in. Let's say you're 22 years old. You get out of school. Most of you right now are living kind of cheaply as you go through school, maybe staying in an old apartment, maybe sharing with roommates, driving an older car. You want to get into once you get into your first good job and you're making good money, some people want to buy a better car, move into a better place, buy some toys or whatever. But what if, instead of doing that, what if you stayed living the way you are now, getting by as cheap as you can and saving up money so you can afford to go to school? How much do you think you could save in that first year working? A lot of money. You think 5,000? Probably more than that. I'm going to say $5,000 because U.S. government, the IRS, says $5,000 a year is how much you can put into what they call an individual retirement account. You can put more into a tax shelter, but an IRA, it's $5,000 a year, I believe, is the limit. Unless they changed it. It was $5,000 last year. They might have bumped it up this year, but we'll stick with it. Yeah. Now, putting it in a safe, let me show you why that's not a good idea.
Well, yeah, you don't get the interest on it.
Yeah.
Now you gotta put it.
Now, right now, they have said that for me, for people my age, retirement to draw full Social Security would be 67. They've also got a plan laid out for that to move up. So for you guys, you're looking at 69, maybe 70 before you can draw full Social Security. Let's stick with 67. How many years is that? That's 45 years, right? Now, if you've invested, now I'm not talking about going to the bank where you're going to get like 0.3% interest. That's not really worth it. But if you went to a professional investment planner and he got you into like bonds and stocks and stuff like that, how much do you think you could make? What percent do you think you'd make every year? It does depend. The average, if you get into a good investment plan in the stock market, the average 40-year gain in the stock market per year over any 40-year period is between 12 and 13% a year. That even includes periods that include the Great Depression in the 1920s and 30s, and 40-year periods that include the big crash in 2008, 2009. So do you want to be conservative and say 10%? So what that means is you're making 10%. Now we're only going to compound this once a year. So what that means is at the end of the year, you have 100% plus 10% or 110% of what you started with. Does that make sense? Just like 102%, there's going to be 110% at the end of each year. So $5,000 times 110% is going to be 1.10 to the power of 45, because it's going to be 45 years. Now, don't punch this in the calculator. I want you to guess what this is going to be. Anybody want to guess what this is going to be at the end of 45 years? It is going to be pretty large. 364,000. I'm just going to round it off to the nearest thousand because, of course, that 10% is estimated. By the way, had that been 12%, you might think, hey, 10% is pretty good. I'm going to settle for 10%. But if you could actually, spend a little money with an investment planner and get 12%, it does make a big difference. It goes from 360,000 up to 820,000. So if you think an extra percent or two interest isn't worth the risk, well, there's your answer. Now, let's say that you decide to not listen to this and say, you know what, darn it, I worked hard to get through school. I got this first job. I'm young. I want to play. Said I'm going to buy some four-wheelers or snowmobiles, boats, whatever, new truck, and I'm going to play. And I'm going to wait till I'm 32. So at 32 years old, you say, okay, now I'll start worrying about retirement. Let's say you scrape together that same $5,000, and let's say you can still get 10%, but now it's only going to be 35 years. Nope, from 32 up to 67, it'll be 35. So times 1.1 to the power of 35 years. 140,500. Less than half. You're almost down to a third of what you had. That 10 years cost you 2/3 almost. Now let's say you really screw up. Now, I'm not saying screw up. It's never too late. I'm 43. Let's call it 42 years old because it fits the pattern here a little bit. Let's say you wait till you're 42 and decide, okay, I'm going to retire in like 20 years. I better start worrying about it. Let's say you can still get 10%, but it's only going to be 25 years from 42 to 67 now. Anybody want to guess? Not quite that bad. 54,000. What you get if you wait that long. So yeah, by waiting till you're 42, you get 1/7 out of it of what you would have if you did it at 22. I got to show you this example just because, well, I wouldn't feel right if I didn't. That's just putting $5,000 away once. 10% interest is fairly conservative. I mean, you can get 12 or 13 if you really wanted to push it. So let's start at that 21-year age. We're going to go up to 67 here again. You put away $5,000 a year. We're sticking to the 10%. So let's see, put that $5,000. You started at 21. Put away that $5,000 a year every year till you're 67. Anybody want to guess? $4 million. Yeah, that's $5,000 a year is a lot of money, but $4 million. That's pretty impressive. Now I want to show you this next here. This person here, let's say they, at 21, they said, you know what? I am going to save. That sounds like a good idea. They start at 21, they save till they're like 27 or so. So you know what? Okay, now you know what? I'm 28 years old. Screw it. I want to play with my money for a while. So they stopped saving at 28 years old. They never put another penny away. So they saved from 21 to 27, and after 28, they played with their money. They didn't save anymore. They still have over $2 million. Let's say this person here does it the opposite way. Says, you know what? Screw that. I'm young. I'm going to play. They don't put any money away until they're 28. Then at 28, they start saving. End up in almost exactly the same spot. If I go one more year here, I'll start 1 year later here. So this person saved for 8 years, from 21 to 28. This person started at 29 and saved for almost 40 years, for 38 years to 67. That first 8 years is worth more than the next 37 years, 38 years. That's my soapbox for the day. You wait till you're 30?
I can do that.
No, I mean, doing it when you're young is better. If you start young, yeah, you start young now and put money away till you're basically 28, 29, 30.
Yeah, that's what I'm saying. Like,
Yep.
After I'm 30, I can start buying toys.
Yep. After then you can. Because which would you rather have? Would you rather you're young? It's nice to have toys when you're young, but if you wait till you're 29 or 30, then every penny you make is play money if you saved when you're young. Again, just my little
You should teach
preaching.
like a finance class or something.
We've proposed it, some sort of financial literacy. Now, if you're looking at doing this, you don't go into a bank. You get a financial planner. There are several. You go open up the yellow pages for financial planners. There's like Fidelity, Edward Jones. There's a bunch of them around. Talk to them. Talk to a few of them. See which ones you like. Ask about fees and stuff like that. I'm not a financial planner, so I'm not gonna get into the tax laws and all that stuff. But it's definitely something to consider. There's income tax things and stuff to deal with too. Now we've got, what we're looking at right now is when you come in on Thursday, we've got another hour of lecture. Depending on how things go, maybe a little bit more than an hour of lecture. And the plan is to get the lecture done in the first hour, and then we're going to do the Unit 2 test in the second hour class. Okay? If we have to lecture the whole 2 hours and do the Unit 2 test and next week, that's fine too. We'll make that work too. For right now, in your book on page 97, 1 through 13, the odds. Some of those talk about compound interest. Some talk about simple interest. Some of them talk about something called an annuity, which we did not get to today. So if it talks about annuity, you can skip over that one, and we'll talk about that more on Thursday.